Hello, hello, welcome back. Happy afternoon. Hello, Xanax. How are you doing today? Hello, hello. Oh, I've got that audio on. Well, at least now I know that YouTube audio is working. And I set up the bot. So now chat can be visible both in the YouTube chat, and if you chat in YouTube, it'll be visible in Twitch chat. At least that's the theory. So how's your all days? Hopefully, pretty good, right? We have a couple hours here, so we'll be able to continue looking into all of this stuff. So, as far as I can tell, we just finished looking through. Let's see. Oh, I must have scrolled to the bottom by accident. Let's see. Where were we? I think we had done props. Oh, okay. So we had optional. Okay, now we can use our component in the main app view. So we did that. So we have a progress bar. Now we can use multiple progress bars. And we got that. Okay, great. Using a component in the view looks a lot like using an HTML element. You'll notice that you can tell, okay, blah, 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 everything's good here. Reactive and static props. You'll notice that throughout this example, progress takes a reactive read signal I32 and not a plain I32. This is very important. Component props have no special meaning attached to them. A component is simply a function that runs once to set up the user interface. The only way to tell the interface to respond to changing is to pass it a signal type. So if you have a component property that will change over time, like our progress, it should be a signal. All right, so that makes sense. Optional props. Right now the max setting is hard-coded. Let's take that as a prop too. Let's add a catch. Let's make this prop optional by annotating the particular argument to the component function with prop optional. Oh, interesting. So we can put this inside of that. Oh, okay. That's interesting. So if we have prop optional, so if we say that our max is optional, let's say, so we'll do view, or sorry, value there like that. So what is optional? Oh, prop optional. And that would be the max. And then we have max equals, okay, yeah, then the max equals max, okay. Oh, so I was wondering how that would look left and right. It looks a little bit weird here, but I guess it makes sense. So if I don't pass that in now, let's say for this one, it will still be valid, and it will be like whatever the normal amount is. Yes, this first one reloaded like just instantaneously. That's what it feels like. The default value on an optional is its default value, which for a U16 is going to be 0, or anything else is going to be a 0, any number. So therefore a 0 is just, it's already filled. Let's give it a particular default value instead. Aha, okay, so we want a prop default equals 100. That makes a lot more sense. So if we go to here, so we can do prop default equals, now 1024, so let's do like 2048. And that way it will only fill to halfway. I feel like that didn't work. I feel like it's still at full. And if we, oh, because I did progress, not progress bar. Okay, so let's actually comment out the normal progress, and we'll only use progress bar, and we'll remove you. Oh, so the x squared will actually work properly. Oh, right. You're not going to work. We'll just get rid of you, and we'll change you. Progress bar. We'll remove you. And so that way, your value is only going to go to the halfway point. Okay, so that makes sense. Generic props. This is great. But as we began with two counters, one driven by count and one by the derived signal double count, let's recreate that by using double count as the progress prop on another progress bar. Ah, so this is where we want to use that double count, where we were trying to get that in. So we're going to have progress equals this double count, which is that that callback function, that closure that we wanted to use before. It won't compile. We declared that. Okay, so its type is a closure that returns an I32. There are a couple ways to handle this. One would be to say, well, I know that a read signal is a function, and I know that a closure is a function. Maybe I could just take any function. If you're savvy, you may know that both these implement the trait function, so you could just use a generic component. Ah, okay, so we're going to use progress bar f. I'm wondering if they're setting us up for, hey, this is not going to work. So, but let's try it anyway. So we want a generic f for progress bar, which is then going to be that f, and then we run. Oh, interesting. Where f returns some kind of I32, so we have to know that type, and then we set the value to be that. Xenix, when I would apply for a remote job somewhere in America, where is a really big salary you would pay taxes there, here, or both? Do I know? I don't know. I'm not a tax attorney, so I don't know what it is. I don't know how it would work. So sorry. Rug Matt, hello. New hairdo. Yeah, I have much shorter hair right now, so it would have been very weird for me to be able to grow this out that quickly. But also, happy Halloween. Yes, it is Halloween. We're channeling our inner Bob Ross here. What is Leptos? Leptos is a front-end framework in Rust. It's probably the second popular, or maybe it's hard to tell how much the popularity comparison between U and Leptos right now. I think U has the edge only because of history. Leptos seems to be gaining in popularity though, and its speed is significantly faster. Whereas U is basically tied with React for speed-wise, which is not a good thing. Leptos basically is only beaten by native JavaScript, and like no frameworks can touch it. You've heard of U, probably from U. Nice. Did I make some scary pumpkins? I did not. We didn't do any pumpkin carving this year. We're not really big on like creating those, like going and buying pumpkins just to carve them up. We noticed that every single time they just start rotting out there, and like then a bunch of animals will come in and sort of like try to eat it, and then they'll mold, and I don't know, it feels like a lot of waste. So I know it's like a fun activity for kids, so I'm never going to like disparage it for them, but I don't feel the need to add to that. So I generally don't. I do enjoy looking at other people's pumpkins though. All right, so let's try this generic. So we're going to take the progress bar. We're going to say I want an f. This is going to be the function. So let's actually do this as the, we're going to take in the value. Where value implements is a closure, is an fn. Yeah, is an fn. That returns an I32. And so we can see, okay, the value here is now going to be this f. Sorry, a value. It's going to be value. And then value here becomes value. Where? You don't like that. Oh, let's see. I think I have to put that in here, don't I? Oh, I'm not allowed to use the where keyword in functions, aren't I? So it's something like that. Oh, value like that. Okay. Oh, it's where is after the impl. Okay, hold on. We can fix this. Where value is an fn let's try that. Okay, now you're upset. Expected value found type parameter value. Right, so this is still actually just value. The parameter type value may not live long. Okay, and that's why they had the plus static, didn't they? Okay, so that was easy enough. And now this should work. It compiles. And that's a lot easier to make, isn't it? This feels like this feels much easier to use generic components in Leptos here than in U. Although we can maybe take examples from this and play around with it and see if maybe that would work better. Okay. This is a perfectly reasonable way to write this component. Progress now takes any value that implements this fn trait. This generic can also be specified in line. So let's see. Oh yeah, I could just do that there without a where command. Note that generic component props can't be specified with an impl yet. Progress impl function to that, in part because they're actually used to generate a struct. Progress for props and struct fields cannot be impl types. The component macro may be further improved in the future to allow inline impl generic props. Interesting. Okay, so eventually they'll add that, potentially. Into props. There's one more way we can implement this, and it would be to use the prop into. This attribute automatically calls .into on the values it passes props, which allows you to easily pass props with different values. In this case, it's helpful to know about the signal type. Signal is an enumerated type that represents any kind of readable reactive signal. It can be useful when defining APIs for components you want to reuse while passing different sorts of signals. The maybe signal type is useful when you want to be able to take in either a static or reactive value. So we could use props into to turn it into a signal. And then the way that looks, so progress bar. So we can signal derive. Oh, I was hoping that like it would be able to turn like the signal and run that into like the I32, so I could just say you're an I32 and the signal turns in and like it makes it reactive regardless, but I don't think that's how it works. Okay, so that's interesting. I'm not sure how often I want to do that. I think that would be more helpful when you have like strings you want to auto convert into like strs or something else like that. Optional generic props. Note that you can't specify optional generic props for a component. Oh, okay, so we cannot make an optional generic prop. It has to be like a full thing. Okay. Yeah, so because it knows, do I have to use option? However, you get around this by using a box dine or dine. Oh, okay. Oh, yeah, so we can use an option and then a box and put that in there. Okay, that makes sense. Documenting components. This is one of the least essential but most important sections of this book. It is not strictly necessary to document your components and their props. It may be useful, it may be important depending upon the size of your team and your app, but it's very easy and bears immediate fruit. To document a component and its props, you can simply add doc comments on the component to function, and each one for the props. So that gives us Rust Analyzer help here. So let's try that. So right now, if I come over to progress bar and I go like that, this is all we have. So, required props, optional props, that's nice. So if I come here and we say, render a progress bar to the screen. So if we do that, there we go, render a progress bar to the screen so we can see that. Required props, optional props. So we have that optional props for the Max i32. So if I come here, I didn't really look at how to do these, but I'm guessing I can do it above here. So we can say for this value, you're going to be, the value is going to be, let's see, so generic value, which must implement a fn. So the component is reactive. And then we have max. Let's see, maximum size of the progress bar. The default is 2048. So if we do that and come back up here, there we go. That's actually pretty nice. I like that. I don't think we get that with you at all. So having something like this is actually really nice. Advanced topic, component transparent. All Leptos components return impl into view. Some, though, need to return some data directly without any additional wrapping. These can be marked with component transparent, in which case they return exactly the value they return without the rendering system transforming them in any way. This is mostly used in two situations: creating wrappers around suspense or transition, which return a transparent suspense structure to integrate with SSR, so server-side rendering and hydration. Refactoring route definitions for Leptos router or out into separate components, because route is a transparent component that returns a route definition struct rather than a view. So then the views would go inside, or like a view would be injected in, I guess. In general, you should not need to use transparent components unless you are creating custom wrapping components. So basically, until you get into more advanced, it's not something you need to worry about. Cool. Iteration, whether you're listing to-dos, displaying a table, or showing product images. So yeah, oftentimes we have like a list of things to look over. So for static views, we can use a vec, and for dynamic lists, we can use a for. So a static would be like one time and then it never changes again, right? Sometimes you need to show an item repeatedly, but the list you're drawing from does not often change. In this case, it's important to know that you can insert any vec where into view. Okay, so a vec of things that implement into view. So like a bunch of HTML, essentially, a vec of HTML. Yeah, if you could render t, you can render vec t. So what that might look like, let's continue with this progress bar fun. Let's say I do a let vec we'll do bars. Now I need a progress bar, so it's can I actually create, I can call the progress bar function, I wonder. No, I have to have a view. So you're going to be a view. We want the value to be equal to, I guess we'll just keep on passing it x. And we'll have max 1024. We'll add 5 more of these right next to each other. And we'll create another div and put them in here. Ooh, it did not like that. Okay, what are we missing here? Open tag is, oh, I forgot to close the tag. Okay, it compiled and there are 5 progress bars. Well, that was pretty easy. And they are reactive, but they don't change very often. I don't think that it's reactive to like show the progress bars. So the thing inside the vec is reactive, but the vec itself is not reactive, if that makes any sense. And then the other one is a for, which reminds me a lot of like a directive in Angular. Leptos also provides a collect view helper function that allows you to collect any iterator of into view into a vec view. Okay, that's interesting. So we have values of that. Oh, because then I can map through them and do some changing and then collect it into a view. Okay, that makes sense. So it's not a collect, it's a collect view. The fact that the list is static doesn't mean the interface needs to be static. You can render dynamic items as part of a static list, which is what we did. You can render a function vec reactively as well, but note that every time it changes, this will re-render every item in the list. This is quite inefficient, and that's why we have for, in case that we want to change like one of the items in the list. The for component is a keyed dynamic list. It takes 3 props, each a function such as a signal that returns the items t to be iterated over, key, a key function that takes, okay, so basically if I take that vector, we can do a for over it, and it'll be a little bit faster. So I wonder if we can just knowing this, I wonder if we can use for. And it takes 3 properties here, each key and children. So if I clone bars, I wonder if we can do, we'll do another div. And then we'll do a for. And so we have each equals, we're going to use bars. We have a key, which is, we don't really have a unique thing inside of them, so it's going to have to be the index, isn't it? A key function that takes and returns a stable, unique key or ID. Ooh, but we don't have something like that. Key is, well, the key. You can add, remove, and move items within the list as long as each item's key is stable over time. The framework does not need to re-render any of the items unless they are new additions, and it can very efficiently add, remove, and move items as they change. Okay, so we need, creating a good key can be a little bit tricky. You generally do not want to use an index because you want them to be able to change. But it's a great idea to do something like generate a unique ID for each row as it's generated using that key. All right, so we need to come up here and give it a key. Give it something unique, which we don't have. I wonder if I don't have a key, if it's going to yell at me. Like most frameworks do yell at you if you don't have a key. Children renders each T into view, but some of them actually let you do it anyways. So renders each T into a view. So children equals, okay. What if I just do this? What happens? Expected a function closure, found a view, I'm looking to see if it's children that it's looking for. It's somewhere in there, but I don't see the exact error. Ninja, hello. What if you add an ID that is the current time or something? Well, the problem is that I don't actually have... It's because your view vec is incomplete. Is that... The view vec has all these views in here, right? So it's trying to run them for bars. It works on the other one, but that's because it's just a view vec. For the keys, I think I can make this a vec of tuples, which would break the other thing. So hold on, let's, I think we need to, well, okay, let's try it without the keys. So let's figure out for children. So for children, it sounds like it's going to be a child. Like, do I just want to return that? No, it expected a return a view. So, okay, let's setup failed. That's not a good sign. So dynamic list, to go find the 4. Okay, so each has the ID. Ooh, where does this? That's interesting. Counters. Interesting. Okay, so this takes 1 to length, map of the index, create, okay. This feels a little bit odd. Oh, each takes a function that returns an iterator. There should usually be a signal or derived signal if it's not reactive. Yeah, they're basically saying in my set, it's a bad choice. If we look at counter, counters, It is something to length. It's basically cheating. It is absolutely cheating. That's one way to do it, I suppose. What are the other things? We have key, so key counter dot zero. Okay. Oh, so each counter, so we just go over it. Key counter dot zero, children. Okay, so then we have this, we have the ID and then the thing. Oh, and then we return a view with the thing inside of it. So this is really more for us to create like a dynamic list. So really what this should be about is we should probably create like a new like bar data. So if we have the vec, maybe we have different maxes, like we have different maxes. Let's start with like, we'll do 1024. So the normal one, the 2000, 3000, 4000, which is silly, but whatever. And I suppose I can make it more in line. So what is it? 2048. And then it's going to be 40, 40, 80, 92, 40, 92. And then, then 8. I used to have to remember these all the way up. And it was years ago. What is it? 8, 1, 8. I don't remember. Like 120 something. That's not going to be right. My math is off. But okay, so if I start with this, but really you don't want to be that. We want every single one of you to be a tuple, don't we? So we want something like a tuple of the ID. So we'll say like ID 0. And then the value, which in this case is going to be max. And then we'll move the X in there too. So the max will be like 1024. Then we'll do it again. So 1 and 2048. And then we'll do 3 total. So 2 is 20, 20, 40. Okay. 40, 92. So, okay, so given that, now we have each is going to be bar maxes. We have the key is going to be equal to bar maxes dot 0, or is it bar max dot 0? Okay, so we have each counters key. Oh, it's a tuple. Sylvie, you want to hang out in here? Come on. Come here. You want? I have a rare treat for you. Mainly just to get you to come on stream with your costume. Come here. Zippy. Sort of a cat costume. It's a little collar with a with his management tie on it, which he does not want to be on camera today. Hi. Do you want to come up here? He's had that tie forever, and if you're on Twitch, that is the tie that oh, you can barely see it. So in the Zilby Cool emote, that was drawn with him having the tie on. Does Zilby run a place? Well, of course, he's the manager. Hi. Here's him taking a look at the place. So of course he runs the place. He's cat. Okay, he's done. Maybe he'll come back and join us again later. He only came because I tried to bribe him with treats. Okay, so where was I? Okay, so key is going to be so we have each bar, and I want to return the bar dot 0. So the first thing, which is going to be that ID. So we have that, and then children, and then you're going to be a bar. And I want to return something that returns a view. So you're going to be a view. And we're going to return a progress bar. With the max equal to the bar dot 1 and the value being equal to x, which means you need to be a move. Expected a function found a vec. So bar maxes. So each do you need to be something that implements move? No. So you're returning that view. And that's it. Okay. So that makes sense. So each equals bar maxes, which is going to be, oh, does it need to be an iterator? No, it doesn't like that. Here, hold on. Let's keep on looking. So each is counters. Counters. Oh, is a signal. Oh, is a signal. So I'm iterating over. There's usually a signal or a derived signal. Oh, I get it. Okay. So it's not going to be quite as easy to make this, to force this. I need to make bar maxes be a signal. So that's going to be something like this create signal that then returns this. So let's do that. So you give me that. We get you those. Okay, so bar maxes is now this signal. That has a vector in it. Each bar is then going to be each one of these. Expected a function closer found so I want to take that in, but you're not, I think it's not what it thinks it is. So initial counters is, oh no, it is. It's collected into a vec. So it is a vec of things. So it's a signal of vec. Oh. I created the signal wrong. I created the signal wrong. You need to be bar maxes and then set bar maxes. Okay, there we go. We got a lot closer. We not only have one error here. Unexpected input node parse failed. So I probably failed to close. Yep, there it is. I failed to close the progress bar. So I want something like that. And now if we take a look, here's those other 3 progress bars that we made. If any one of them change or reorder them, it doesn't have to redo all of them. It doesn't have to re-render every single one, just the full list of where they are, which is nice. Okay, perfect. Iterating over more complex data with for. This chapter goes into iteration over nested data structures in a bit more depth. I think that this would be fairly easy to sort of grok, but probably one of those things where, sort of like as they're mentioning, skip it and come back. We're going to stick with the simpler subjects for now, but most likely because I think it's going to be fairly easy to like figure out how to loop over them, because it's just data structures. It's just sort of like understanding where things are. So I'm just going to move on to forms and inputs. Forms and form inputs are an important part of interactive apps. There are 2 basic patterns for interacting with inputs in Leptos, which you may recognize if you're familiar with React, Solid, or a similar framework, using controlled or uncontrolled inputs. Controlled inputs. In a controlled input, the framework controls the state of the input element. On every input event, it updates a local signal that holds the current state, which in turn updates the value prop of the input. There are 2 important things to remember. The input event fires on almost every change to the element, while the change event fires more or less when you unfocus the element. You probably want on input, but we give you the freedom to choose. The value attribute only sets the initial value of the input and only updates the input up to the point that you begin typing. The value property continues updating the input after that. You usually want to set prop value for this reason. The same is true for checked and prop checked on an input. Okay, so that reminds me more of like Angular, especially like old Angular. So we have let name and set name, create signal, controlled. Okay, so basically we're going to have an on input, and then it just does something, and we set the name, which is going to be what this is, and then we can just display prop.value is going to be the name. The prop syntax lets you update a DOM property rather than an attribute. Okay. We already, oh, because we did that with like style. It's like, that's how we did the style stuff. And then we can bind it to something else with like name is. Why do you need prop value? Web browsers are the most ubiquitous and stable platform for rendering graphical user interfaces in existence. They have also maintained an incredible backwards compatibility over their 3 decades of existence. Yeah, it means that there's some quirks. So basically, if you leave this blank, and we can play around with this. So let's create an input. And also, just because we know how, we're going to create a component for that, just so we can make sure we're working in a stable environment. So we're going to do a component. We'll have a function. Let's just call this an input component. We can have an initial value, but I don't think we need to worry about it too much. We're going to return an impl into view. So we need some kind of value, and maybe we'll like start one thing at a time, right? So we're just going to return a view. Input, we'll have type is going to be a text. Let's like not put anything else in. And we'll just start with that. Okay, and then we will add this in down here. Oh, right, I'm supposed to have a capital I. Surprised and a little bit sad it didn't yell at me. Okay, so given this, here's our lovely input that we just created. Now, if I want the value coming out of it to be matched with something else, now, like previously, I think it was like model, like Angular had like a model, and like Vue has a model that allows us that like two-way binding. And this is sort of like a hybrid between them, where we're going to catch the input, stuff it into something, and then print it somewhere else. So let's this is probably not the best design, but we'll like put something right next to it for what's going inside of it. So we'll have not in view here. We'll have let value equals create not action. What was it? Create signal. Create signal, and then the value is going to be nothing. What are they using for this? They're just using a full string. So if I want nothing to begin in there, so we're going to have just a new string. And I keep on forgetting to tuple this. So we have value and set value. I want to, on input, we're going to have the new value. And I guess in this case, it could just be value. And we're going to now set value, the value. Expected string, ooh, but like, can I do string value dot value? Value of? Maybe? What did they do? Set name, oh, so they got the event target value and then passed it in that event. Interesting. So it's a different function that sort of allows you to extract out. That's a nice helper function there. So this is going to be the event target value, and then we want this to be an event. Niank, hello, Leptos. No need to write JS code, right? That's like the theory, right? But in practice, I found that it's very helpful if you're willing to write a little bit of glue code. Mostly because there's some things, some like libraries or some other services you want to use in JavaScript, and it might be a pain to pull them in using FFI, but instead you can write a wrapper around that and then call in using FFI the wrapper and then just run that. And that ends up being a lot easier. Okay, so if I do that, now let's add in, we'll just do a p tag here, and we'll pass in the value. So if I type in, that works, okay. That just works. Now it's suggesting that we need to add in the prop value here. I was kind of expecting it to not work the way we wanted it to, but I think basically it's saying, hey, we need to do that just in case. So it's possible that some browsers won't work properly with this. So if we now set the value to be equal to the value, so this would be what, prop value equals value. Then it works just fine. That's really nice. Uncontrolled inputs. In an uncontrolled input, the browser controls the state of the input element rather than continuously updating a signal to hold its value. We use a node ref to access the input once we want to get its value. In this example, we only notify the framework when the form fires a submit event. So basically, we don't care about that, but we do care about a form. And then we have this, okay, so here's on submit. It's going to be this closure that takes the submit event. We take, where is input element coming from? Our onSubmit handler will access the input's value and use it to call setName. But where is this coming from here? There it is. Node ref input create node ref. Oh, okay. So we create a ref, but how does it know? Oh, that's the input that we created, isn't it? It's a smart pointer. So it's basically like a ref from most other things. So I can now use that to like expect it to exist in the DOM, and then I can get the value of it at any time that I want. That's interesting. So if I have a form, let's see another one here. So we'll create a form. Now, I don't actually know if I need something like this. Let's return a view first. We're going to turn a form view on submit equals. I could just do let's do the closure out here. So submit. I don't necessarily need a move for this one. So you're going to be on submit. So your form. Then I want in here, I want the input, which you don't take any properties. So you're just like that. And then we close the form. We probably do want to take something. So we probably want like a name, which is going to be a string. Or I wonder if this could be a stir. So name is going to be, let's just say, I don't know. We'll do the simple name. Okay, so we set the name there. Ooh, you don't like that. Missing lifetime specifier. Ooh, I was really hoping that I wouldn't have to do a lifetime specifier for a stir. So I wonder. Let's try, we'll just make it a string. So you're happy. Oh, except for mismatch types. This is where that prop into would come in handy, right? So we say for you, prop, what is it? Prop into, something like that. All right, that works there. Oh, you're upset again. Oh, for that input, you require a name. So name equals other name. It's gonna be fine. Closure expected to take one argument. Oh, but it takes none. So you need the value, the event. So we have this submit event. And we can just immediately do event dot prevent default, so it doesn't refresh the browser when we hit enter or do something like that. Type annotations needed. Oh, interesting. So we need to specifically tell it that it's a submit event. Okay, that's good to know so far. Now, if I want to get access to, so let's see, let's add in a button here. The button should actually, we can give it a type. Now, I want to log this. They haven't told us how to log things out, have they? So I won't be able to see that yet. We'll figure that out later. I'm actually kind of surprised that it didn't start with like a log right up top. That must be like pretty far down. Okay, so I prevent the default. Now, if I want to have like the name or something like that, so we're gonna do let. So let's just do the name, set name. And this is going to be an empty string because that's what's in a anything, any of these things we got. Joan423, hello. How are you doing today? What a funny haircut I got. Yeah. Don't be surprised when it's gone. We're gonna have a pretty drastic change tomorrow. Youssef, hello. How are you doing today? So we'll do a new string. All right, so we have you. That means we're gonna need to move you in here. And now, okay, so if I want to get access to this, we need to create that that node ref. So here is going to be the let the ref to the input. So the input reference is going to be equal to the, what is it? Node ref? Node ref. Okay. And what did they do? There was node ref. Oh, it was just, yeah, okay. Oh, I said what the type is. I wonder if I could also do that from create node ref. Create node ref. And then you're going to yell me about the type. Can I do turbofetch syntax and say that I want this to be an input? Constant provided when a type was expected. Input is a function item, not a type. Ooh, okay. So interesting. Joan, you can't get into the IT world. It takes a lot of time to focus on. It does take a lot of time to focus on. Like if you've never been in the IT world and you're trying to break in, there is a, I wouldn't say it's like a super high bar, but it's like there's enough of a bar in there that there is a significant amount of like sort of initial work to break in. But that's a lot of like other things too. Hello from YouTube, but Stacking, you wrote that into Twitch chat directly. Also, hello, how are you doing today? Are you happier if I create this as a type here? No. Okay, so how do you know what type this is? You refuse to chat on YouTube. We just pretend to chat on YouTube, right? So, I'm guessing. Oh, I bet on here. Node ref equals input element. Interesting. Okay. So I would need to take in a property of the type for input. Whatever that is. So there must be like an input type. I wonder if we can find that. So it would be something like Leptos input. Oh, there's no input here. I wonder how we'd find this. You keep forgetting you no longer have to pass context in every single prop enclosure. That was kind of hell. Oh, they used to make you have to do that? Oh, that would have been, yeah, that would have been not fun. But yeah, no, you don't need to do that now, which makes it really easy to create components. It's like the best part about like waiting for things is then I get to skip all like the really troubling early times of technology. It's still a little bit unfortunate that to get the best things you have to the documentation recommends nightly, because that makes it really hard for me to recommend for anybody to actually use this. I'll have to like review what can we do without nightly, because that might if we can still do like pretty much everything we want and we can just like skip everything else, then that would make it good. Context held the node into the tree, so if it was reactive, it needed to be added to the tree. Oh, so now it just sort of figures it out. Nice. Okay, so we use node ref to fill the node ref. Older examples sometimes used underscore ref. They are the same thing, but node ref has better REST analyzer support. So I can basically, okay, can I maybe tell you not to do this? Sylvie, you're back. Do you wanna hang out? Hi, you wanna come up here? Hi, you wanna jump up? No, just wanna. Oh, we put his plate down here. He's here to eat. Okay, so if I create node ref, you're gonna be upset, but maybe if on this, it wouldn't be. Ooh. So let's change this to be like a real input. I think it would be a little bit more advanced to figure out how to like pass the ref in. What I would probably prefer to do is just grab the name from the submit, because that's usually what I do. I don't actually like in React to use refs at all. So hold on, let me see if we can do that. What if we skip the entire ref thing? And if instead, is there like a getter on, so it wouldn't be target value. It'd be like get form. Form data. The form data event, which receives event as its argument. That's a struct. Form. Close. So if I do that, the form data event. So form data. Oh, so I can do from. Is there like a new? Ooh, I don't see like a new. But maybe I can do from the event. Expected form data found submit event. Okay, so that's not what I want. Can I do, what do we can get this? Target, event phase. Can I get form data out of here? It's not looking great. Getter for the submitter fields, that gives me an HTML element. We get the target, which I don't think we want. Yeah, I don't think any of these things are what we really want. We can get maybe target, I think would be like the bubble, like the button that got pressed, maybe, possibly. What would you be? So that thing equals that. We can unwrap you. Is there a log? There is a log, so I can log what the thing is. Maybe. Argument must be a string literal. Okay, so can I toString you? Ooh, no. Okay. So you're not telling me what I can do with this. That's not That's not great. You are, though. There is a toString. Okay, so I can get toString. Yeah, it's not really helpful. I bet as string is not going to work out for me. Format must, oh, what? Oh, this, oh, I didn't realize it must be something like this. Oh, okay. I got it now. So maybe I don't need that as string. I just need that. And then in the console here, okay, whatever. We have some warnings. It's fine. So I do that, and I want to hit. I don't apparently have a button anywhere. I thought I created one, but whatever. If I hit return, oh, it still doesn't work. You know what? With the button, I probably need to actually give it something in here. So submit. You're unhappy. Oh, this is something else. Did I never put form in here? Well, that'd also be helpful. There's our form. So we can test something out in here. So we can just type whatever. Hit submit. Oh, but nothing happens. So what I was hoping to do would be to have this log out whenever the submit event happened. And I was also hoping that the button type submit would would submit the form, but it kind of needs to be inside the form, doesn't it? Let's try this again. There we go. Okay, so event target, we have object, JS value. Okay, so our object, so it's an object within an object there. So now can I get the object? What can I get? Thing dot dispatch event. Ooh, I don't know how to get like a form event from there. Ooh, that'd be really nice, but maybe. Can I do a form body or whatever it's called? What was it? There was the form, well, form data. That's what it is. So form data. Oh wait, there's a form data function. That's the event. There's a get. There's no get form data. Get config, get snippet, get other things, but not stuff that I want. So if I do a form data, so let's create. I want a form data. Oh, that's a web sysform data. Hold on. I want I can get form that way. I can get form data. Okay, so can I do this, which is then the event. Expected function found form data. Not sure that's what I want. Oh, and these are so it's like basically some macro magic happening behind the scenes there. That's what's going on with that. I bet there's a way for me to get the form data, which is usually what I prefer to work with rather than work with like refs. And if I want to pass in a ref as a optional thing, I wonder if we could do that. So we say input. For this input, I want a ref, which is going to be a node ref. Oh, is this a special keyword? Let's do node ref. Is this node ref missing generics? So it needs to know what type this is going to be. So this is going to be a input. The only problem here is that I named this input. So let's do our input component. Means you need to be input component now. Oh, and now I find value of input component. Did I rename it? Input component. Okay. Node ref is going to be an input. You have two closing little tags there. Can I find type? Okay, bring in that input. I want you to be optional probably. So what is that? Prop. Don't know if I can do like there's no option. Ooh, how do we do the option again? Components and props. Oh, prop optional. That's what it was. Okay, so then if I have that node ref, we do that. Then we have, was it node ref? Equals node ref. Okay, doesn't hate that. So then back to our form here. We're going to have a node ref that we pass into you. So let node ref equals, which is going to be a type, node ref of input equal to create a node ref. We have our input, node ref equals node ref. Andrew, hello, how are you doing today? Thank you. I think the very first thing that blew my mind about Leptos is then building docs on the fly and giving function hits. That's really nice. That is a super, super nice thing. And I wish that I would have that in pretty much every other framework that I've worked in. All right, let's not worry about the log here. What are you upset about? Expected value found struct input. Oh, right, because it's now input component. There that goes. Okay, so I have my node ref. We pass that in. We can move you in here, and then I want the value coming out of here. So node ref dot. So how did you do this? Back to forms and inputs. So here's our node ref. Oh, I call it as a function, and then I can, okay, so then I unwrap it because it's an option. So we call you the function, we unwrap you, and then we can get the value of it. So I get the value out of that, and then we can set this the name to that. Or we can log it out, right? So we can log the value. And then we don't need this at all. So now when we type view, we hit submit, we get that logged out. I mean, it's nice. I wish I didn't have to use the ref for that. I'm sure there's a better way to do it. But that might be something else to sort of get into. But we can basically pass in no refs everywhere we want. And I can basically create wrapper components around all the components. And I think it's a really good pattern to create basically your own component library that wraps around all the other components. That way you can work with CSS and other things. Control flow. In most applications, you sometimes need to make a decision. Should I render this part of the view or not? Should I render button A or widget B? This is control flow. When thinking about how to do this with Leptos, it's important to remember a few things. Rust is an expression-oriented language. Control flow expressions like if X, then Y, else, and match, blah, 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 return their values. This makes them very useful for declarative user interfaces. For any T that implements into view, we can then basically use that, right? So basically, if I have an if statement, I could just return anything that has an into view. Values must be functions. You'll see me constantly wrap things in a move closure below. This is to ensure they actually rerun when the signal they depend on change, keeping the UI reactive. Okay, that makes all sense. So what? To connect the dots though, this means that you can actually implement most of your control flow with native Rust code. So basically just create a function that returns something or the other thing. And that's very similar to sort of like, that's a very React-y, like a React type way to do stuff. You see this all the time in React. Oftentimes though, you see it more in, oh, what's that inline if statement called? I use it all the time and I just blanked out on what it's called. Ternary. Yes, thank you, Andrew. Yes, a ternary statement. Was it a statement or was it an operator? I thought it was a statement. And you can put wrapping into a sum or none. Okay, so I mean, this all makes sense. So basically I could do, let's say I want to, on this input type here, we're only going to put the value if there is something in the value. So I think I need to do a block here. So we're going to do an if the value, and I think I can just get access to it. Oh no, value is empty, because that gives me the string, right? So and I need the full thing. So let's create that up here. So let's let print like debug equals, gonna have a move in here. So we're gonna do if the value of that is empty, is not empty, right? So if you're not empty, I want to return sum, and then the view with that p value. Otherwise, else we want to return a none. Ooh, it doesn't like that. Okay. There's so many open brackets here. One of them is missing. So if, okay, so move that. So if not value is empty, we return sum, open. So two opens inside of here. So two closes before closing that. Oh, and then missing one right there. That's all it was. Comkick, hello, how are you doing? What happened to the exploring hat? The exploring hat is right down there to my right. It doesn't fit with this hair. So next time we're exploring, we'll put the explore hat back on. This is not browser. You should close P. Did I forget to? Oh yeah, I forgot to close P tag. That would be a thing. That is actually something that's nice that U gives me, is that their HTML macro does a better job, it feels like, of telling me when the HTML is invalid. Whereas this sort of is like, whatever, it goes. Okay, so you're upset now. So we still have a problem. Missing semicolon, because I had too many closing brackets there. That's the problem. Okay, so now I want to put, now we just render debug and we get rid of you. And so if we come back to here, nothing should be displayed, which I suppose we can look at by looking somewhere around here. And then we start typing and bam, this P appears here. What's the best way I can do this? We can create a style, can't I? I want to do, for all P tags, I want a background color of like red, blue. Oh, weird. No. A background color of red. Red. Okay, so that shows there. Let's also give it like a minimum width of like, I don't know, 50 pixels. It's like you have min width of like 50 pixels. There it goes. So even if you're gone, you should still show up. Patatas, hello. How are you doing today? Now if you disappear, it's gone. So that's our if statement showing up. Oh, add an outline to them. That's a good idea too. Let's add an outline of like 2 pixels, solid, like green. That way, if it's still not there, it would show like an outline, and it shows up as soon as we have anything, like as soon as it's there. But it's it actually disappears because of that if statement, because it's a none. So perfect. This works fine. We can make it a little shorter if we'd like using bool then. So the message move is odd. So do the thing that is already a Boolean and then dot then, and then do the thing. Oh, because it would then give me an option, wouldn't it? So that's nice. So we could change that around. So debug is empty, and then nope, undo. Dot then we pass you in, and then it's simply going to be this view here. And then I shouldn't need you at all. I actually don't need the if either, do I? Okay, where did I miss? So you're going to there. Cannot prior interrupt to not. Okay, so oh, interesting. Is there like a is empty not? It's then some. Oh, okay. Oh, yeah. Return sum if the Boolean is true. Return sum if the Boolean is true or none otherwise. That feels like that's... No, it's not then some. It's something else. It is... No... Then some, then... Is there something for like the not of it? Oh, wait, not. No, those are snippets now. So is empty isn't even a choice on here, interestingly enough. Well, is empty is a... Oh, wait, is empty. I want to do is some. Well, I guess like... is there like a not is empty? So I want to have, let's see, what is that? It's a string. So as_stir capacity as bright is empty. I'm going to do a length. That's not a Boolean. I need to turn it into a Boolean. Ooh, okay, so contain starts with, ends, finds. I don't think there is a like a not in here. Or like a not empty. Yeah, that makes it okay. So we can only do that logic if we have it be a truthful thing. An extension trait to add bool to add not. I've never done that before. That would be like an interesting sort of exploration to see how hard that is. Right now it would be the exact opposite, right? So if I do value is empty, if it's empty, return this. So hold on, is empty. then return that. So it's basically going to have nothing in here all the time, which apparently didn't work the way I wanted it to. So this would be more of us saying like, hey, write, oh, is there a dot else in here? So hold on, nothing to see here. So if we do that, you don't show up. Okay. Trait bool extension, function not self to self, then impl bool extent for bool, or something like that. Interesting. Okay. Maybe sometime we'll take a look into that and sort of play around with like extension traits for all sorts of things. It could be fun. Okay, so value, we get the string is empty bool dot then. Why isn't this showing debug? Shouldn't that show it here? Like, okay, you don't show up there. Did I screw up? No. You should show this here, right? So if it's empty, unless for some reason it's not empty. Oh, use standard ops not, and you could use not. Oh, so we could just basically just use their own extension trace that they already have. That could be interesting. Is there like a dot not? Oh, okay. Can't do not already. I don't think there's a then. There's not like an else or something. And then. Ooh, there is an or. Return to the option T or else with function. So what if I do something like this? View. And then inside of here, we're going to put in the value, and you need to move. Mismatch types expected, an option. Found a struct Leptos HTML element. Oh, do you need to be a sum? That's weird. No, okay, so we broke it. So is empty isn't actually returning what we think it is. So we have the value coming out. The value is string, but maybe it's not actually like an empty string. Maybe there's something else going on with that. It would be nice for us to see what... Well, we see the debug here. What if we just do another value like that? Just to see what we have going on here. So we have nothing... Now we see... Okay, is empty, nothing to see here. And then you show up there like that. Okay, so now it's working the way I expected it to. Was I not saving that properly? And then... Oh, don't want that. And then... So there was the or else. Okay or else. Oh, I was really hoping that would just magically work. Method into view exists for closure, but its trait bounds are not satisfied. Oh, okay, or else returns a result. Oh, yeah, okay, you're right. That converts into the result type, which I don't want. What else? So, or else, if we just do or else, you need to be an option. Nothing to see here. And then that returns there. Okay, so we got it. That works. So now I can remove this value here. So this debug here starts with nothing to see here, but then we can change it to be whatever the thing is. And that way now we can have our cake and eat it too. So that makes it a lot more functional too, which is really nice. Why is click me strong? So that's something we did this morning. So if we come up to the top, we basically set an interval. So every 16 milliseconds, so 60 frames per second, it increases the value of our X state by 1. And we set the value of X on the button. We set its position to absolute. We set its left to be X pixels. So every 60 times per second, we're having it move around. So that's why we're doing that. Marquee. So wait, we recreated it. Of course. Why wouldn't we recreate it? And then that stops as soon as it reaches 1024. And then we have loading bars to show its position, to see how long it's taken to move over all the way to the right. Okay, so match statements are going to be exactly the same, so not really all that surprising. Preventing over rendering. Everything we've just done is basically fine, but there's one thing you should remember and try to be careful with. Each one of the control flow functions we've created so far is basically a derived signal. It will rerun every time the value changes. In the examples above, where the value switches from even to odd on every change, this is fine. But consider the following example. So we have something like a state that's 0, message move if value. So if the value is truthy, or if the value is greater than 5, then big and small, okay? This works for sure, but if you added a log, you might be surprised that it's going to log a ton of times. So we have this logging log, rendering big. Every time value changes, it reruns the if statement. This makes sense with how reactivity works, but it has a downside. For a simple text node, rerunning the if statement and re-rendering isn't a big deal, but imagine it were like this. It puts a component in there, which is now going to cause that component to re-render as a full. This re-renders small 5 times and then big infinitely. If they're loading resources, creating signals, or even just creating DOB nodes, this is unnecessary work. The show component is the answer. You pass it when a condition function, a fallback to be shown if the when function returns false, and children to be rendered if when is true. So basically, it's like an alternative to if, right? So show when, and then we figure out when that thing is true, and then, oh, it's probably going to do some calculations to determine whether or not it should show it, right? Show memoizes, yeah, exactly. So it's going to basically cache the contents of what goes in. So it caches this big, and it's going to change. It's going to check to see, ooh, have you really changed values? Because if you're exactly the same again, I'm not going to do it again. So it's a wrapper tool. So I wonder if this is that transparent wrapping that it talked about earlier. This is a helpful tool to avoid re-rendering when using dynamic if expressions. As always, there's some overhead. So I like this. This is really nice. Type conversions. There's one final thing it's important to say in this section. The view macro doesn't return the most generic wrapping type view. Instead, it returns things with types like fragment or HTML element input. This can be a little annoying if you're returning different HTML elements from different branches of a conditional. The strong typing is actually very powerful because HTML element is, among other things, a smart pointer. Each HTML element T type implements deref for the appropriate underlying web.sys type. In other words, in the browser, your view returns real DOM elements, and you can access native DOM elements on them. But it can be a little annoying in conditional logic like this because you can't return different types from different branches of a condition in Rust. There are two ways to get yourself out of this situation. So we can do into any to become any element, or into a view. But I suppose, like, because any element doesn't have all of the methods on it, that might be something also annoying. So this feels like something that we'll have to dive into once we actually do something that requires it, which is going to be more of like a real app that we're building. Okay. So unfortunately, we're pretty much done for the day. We got through a decent amount of it. We looked at, I like what I'm seeing with Leptos. I want to build something real with it, and then we can build a course for it because that would be a lot of fun. I'm thinking about like building an actual application first, then we build a course. Because building an application, make sure that we run into all the problems that we get from like, maybe not like a large app, but at least a like small app, and one that's not a to-do app. We want something more real, something that like I can use. I'll have to figure out what that's going to be. But so far I like Leptos. I like it. I do definitely like it a lot. What was it saying in for nightly? Okay, so what do we not get? Oh, so basically we don't get, so we have to use the get, read signal get, write signal set methods instead of calling signal setters and getters as functions. Wasn't there for that with the, was it dynamic attributes? Yeah, so do count like that. If I do count.get, it's not reactive, right? I guess if this is just text, any is not too bad. It can only be a problem with interactive stuff, but in such a case, you need extra code anyways. I think it's more of like when you want, if you know you need a very specific type of element from it, like, oh, this is like a form, or this is an input, or if it's one of the many different types of form inputs, like it's an input element, it's a text area, it's something like that. I want something that implements like value that you can get the value off of. So I'm curious about like how that would work, but maybe like the get value function helper that they provide you would work with that. And it would just give you an option back saying like, hey, maybe it has it, maybe it didn't. Who knows? You get to figure that out on your own. You like how they don't use effect. Use effect is one of those things where I don't like it because I don't like how generic the name is. I like how powerful it is, but like with this, I feel like we're not missing it, right? Like that you're not missing use effect. And it's just as powerful. Like you can do all the same things that you would need to do with use effect, but you can do it here anyways. Create effect it is called here. Oh, interesting. I guess we haven't gotten to the point where it's like creating effects and doing stuff. So that's probably down farther. 4.2 in a book. Oh, so it's in reactivity. There it is. Responding to changes with create effect. Okay, so this is interesting. Well, I'll probably come back and take a look later. Of course, right now, we have the I'm still working on the LMS, which is in U. I'm not about to just rewrite the entire thing in Leptos right now. Maybe in the future we can do that. That's certainly, like, not off the table. It's like the entire thing is an MVP, and it would be ironically not slow to like rewrite everything, because we now know what everything is supposed to be. And so like the design pattern's already there, and we just need to figure it out. So I'm not afraid to do that if it's called for. So we're gonna go back starting tomorrow. We're gonna go back and continue the data table in U. And I'm also going to be, well, I don't really know if I have anything else. Rewrite MVP book and MVP framework. Yeah, just like rewrite everything and whatever new comes out. I would think I would probably rewrite something else rather than the something else in Leptos before I would tackle the LMS. Because the LMS is like now actually has users in it, and I don't want to risk like breaking it for everybody if like, we screw that up. So I'll probably create like something else. I have some ideas from it, but I don't know for sure yet. So that's gonna be tomorrow. So everybody, thank you so much for hanging out with me today. And tomorrow we're gonna be back to normal. Not gonna be dressed up in the fun Bob Ross outfit, and we'll be back to you. So with that, have a great rest of your Halloween, and I will see you next time. Bye.